Good morning, everyone, and welcome to LEC's monthly bioeconomy webinar series. We are thrilled to have our team. We're thrilled to have current customers and prospective customers joining us today. Looks like we have about 40 people already on the line, which is a good showing. And I think we're ready to get started. So without further ado, let's move to our agenda, which will look very familiar to our participants. So we're going to kick off with some housekeeping items. And for those not familiar with LEC, we'll be doing a one-page overview of the firm just to kind of give you a sense for what we do and where we do it. And then we're going to move into our speaker, Dr. Michael Köpke, who is a retread, not a retread, but a repeat. He was with us a year or two ago to great fanfare, so we're excited to have him back. That's going to be 20-25 minutes, Michael. I know you have a lot of slides, so we're going to have to move through those pretty quickly. And we will conclude about 11:25, 11:30, and then we'll move into Q&A. For those participants, we have a Q&A tab you can see at the top of your team screen. And we would welcome and encourage questions for Dr. Köpke in that format. As you are called on, we are going to ask you to unmute your microphone, and we're gonna let you ask the questions directly rather than reading them. So we're excited about that. Then we're going to move into some expert recognition. We've got 2 new experts joining us and a longtime LECer that we are providing a LEC All-Star Award to, which we're excited about. And then we're going to close out with some parting reminders and then send everyone back on their day. So without further ado, let's get housekeeping out of the way. This is a new format. I think we're in month 2 or 3 of using this new webinar format. It's slightly different than the old format, but we are going to be recording it, and it's going to be a valuable resource for us that we will look forward to having folks watch who can't join, et cetera, et cetera. Please mute your microphone when not speaking. At current, we have control over your mic, but again, for Q&A, we will open those up, but we do ask you to unmute yourself to ask the Q&A questions. And then, as already reminded, please feel free to use the Q&A tab at the top to enter your questions. Okay. Next up. Okay, so LEC, for those not familiar, LEC has been around for almost 30 years. We are a global consultancy. We started in North America, but we have expanded throughout the world. We have north of 150 experts, and they average about 30 years of experience in the business, in their particular niche. And one of the things that I think draws clients to us is the fact that over those 30 years, we've experienced and made lots of mistakes, and we help our clients avoid those same mistakes in their projects. And it's really one of the magic reasons that LEC has been around as long as it has, and how we are really honored to see our repeat client business increasing significantly over the last 2 years. About half our folks were C-suite executives in a CTO role, CIO role, CEO role, et cetera, and the majority have advanced degrees. There are a handful of us with MBAs, but most of those are PhDs, and we have evaluated north of about $3 billion worth of projects, which is just pretty astounding. We go through a variety of services in a variety of verticals. As you can see on the screen, I won't bore you with reading each of them, but this firm has been growing significantly over the last 2 or 3 years, and we're excited that you're here joining us today. All right. Dr. Köpke. So Michael, I'll refer to you as Michael. We had a chance to catch up before the meeting. You have an incredible career. You've been at LanzaTech in a variety of roles since 2009, and we are thrilled to have you. LanzaTech represents probably one of the names that comes up most often in our SAF projects, and you guys are leading the way in a variety of areas. I know SAF is just one of them, and we're really looking forward to hearing from you and learning more about your business. So with that, let me turn it over to you, and hopefully we can keep it to 25 or 30 minutes if that's possible.
That's great. Thanks, JD, for the kind words and introduction. Always a pleasure to be back and talking to the diverse experts of this group, and really appreciate all the discussions and the support over the years from LEC. Happy to share some of updates about LanzaTech. I think we're a public company now, so I think quick disclaimer about forward-looking statements. We don't need to spend too much on this slide. I think we can go to the next one. Yeah, in its heart, the mission of LanzaTech is really about capturing and transforming carbon. And we're not traded on NASDAQ. I think we're the first carbon capture and transformation company on NASDAQ. If we go to the next slide, so I don't need to spend too much time probably to explain to this group why this is important. I think we're sitting on a climate time bomb, and if you go to the next slide, a lot obviously comes back to our linear economy and the release of greenhouse gases like CO2 into the atmosphere that sharply rose since the industrial area. But carbon's not really the enemy. In fact, I think it's the base of everything in our daily lives. So I think if you go to the next slide, but we really need to think carefully how we use our carbon. Power, in fact, I think can be carbon-free. We have a lot of mature renewable technologies now. If you go to the next slide, fuels, however, especially if you think about aviation, I think we'll need carbon, I think, for the foreseeable future. There's obviously battery technology, but I think for transatlantic, transpacific flights, I think that's still at least a good period away. And I think we need to bridge that, of course. And then if we look at chemicals and our everyday materials and what we use most of the day, I think these are all based on carbon. I think most are kind of hydrocarbon products that we use. So if we go forward, it really, where this carbon comes from will define our climate future. And our belief is that the world already has enough carbon above ground to make everything we need, especially if we can tap into some of these waste resources and the carbon we release right now into the atmosphere. So if we make use of that, I think we can avoid digging out more fresh fossil and enable a circular economy. In fact, I think by 2050, I think the world will be generating 3.4 billion tons of trash per year. So if we continue, I think looking at that, I think there's really, I think, a couple steps. One, of course, I think reduce our carbon emissions, reduce our waste. But then the other step is really power the circular economy and get to a steady state where we have that carbon and keep that carbon in circulation. And that's really where I think LanzaTech comes in. But if I think about circular carbon economy, I think biology really comes to mind, and this is really what drove me into this field. If we go to the next slide, if you think about nature, there's really no such thing as waste. I think everything's really recycled down to the very atom. I think, just consider the cherry tree. I think that makes blossoms and fruit for us, for birds, for other animals in effort to grow the tree. But then once if these fall to the ground, they're not waste. I think, in fact, they're feeding other ecosystems that in turn, I think, nourish the tree and the soil itself again. And taking inspiration from that, I think we're also looking to apply at LanzaTech biology to enable a kind of a circular model. And it turns out biology is already fixing CO2 since a billion of years. Potentially, I think where life on Earth started, I think down at those hydrothermal vents in the deep ocean, you have CO2 floating through those hydrothermal vents. You have reduced conditions. You have transition metals. I think that's potentially where life on Earth started. But if you compare those to, for example, an industrial smokestacks, they're actually not too dissimilar. Now, if we go to the next slide, I think there's today, I think at least 7 known biological CO2 fixation routes. I think when LanzaTech started, I think those first 6 were known. And there's really one that stands out, and I think that it's linear and not circular, but in particular, I think since it's the most energy efficient one, if you click once, you can see, I think it consumes less than an ATP and the least amount of reducing equivalents. And the group of the late Aaron Bear-Evan also mapped out and every kind of biological data that's been reported, and you can see in red here, this Wood-Lungdahl pathways or reductive acetyl-CoA pathways is really the most energy efficient. It has really very high energy efficiency. But if it goes one step further, I think the challenge with this pathway is it's based on a variety of very delicate metal enzymes, and those are very oxygen sensitive, so it's only found in anaerobes. And only found in these anaerobic acetogens. And it's quite a complex pathway, so it's also very difficult to, for example, transfer to model organisms like yeast or E. coli. If you look at the pathway, it can accept 2 molecules of either CO or CO2 and then fuse that together to acetyl-CoA, which is really one of the building blocks of life from where the cell grows, but you can also make products. It's actually quite important that this organism also able to not just use CO2, but also CO. In fact, it can also grow on purely CO. In that case, it essentially has to waste some of the carbon to make its energy, so it can essentially perform a water gas shift reaction through this carbon monoxide dehydrogenase enzyme, produce its own hydrogen or reducing equivalents. But then if you click once further, I think once you add hydrogen into the process, I think you can really achieve 100% carbon capture down all the way to using CO2 and hydrogen. So I think that flexibility of the organism to use CO, but also use hydrogen and CO2 is really important. It enables to be able to use a diverse range of different feedstocks. And in particular, I think many of those industrial gases are still rich in CO, so you can make use of that as well. If you go to the next slide, I think most acetogens actually produce only acetate, but there are some acetogens that also make other products like, for example, ethanol. And for us, that was really important. I think having an organism that's for one, industrial robust, but also they naturally make already product that's valuable. That's a building block of the industry, which I think ethanol was. And initially LanzaTech screened a wide range of cetogens, and we came down to this one organism, Clostridium autoethanogenum, which sounds complex, but it comes from Greek auto for self, eta for ethanol, and then genome for generating, so essentially generating ethanol by itself. We click to the next slide. Yeah, what really LanzaTech is, a lot of LanzaTech is about really taking that biology and then combining that with industrial scale. I think you can think about it in a very simple term, like a brewery that plug into industrial plant, where we use the waste of that plant. But of course, I think it's more complex if we click through once or twice. I think I can go through more of the process in detail. We can take a variety of different input gases. There can be industrial off gases, can be gasified wastes, solid waste, or also CO2 and hydrogen, where we then feed those gases into proprietary bioreactors that we've developed, where our carbon-fixing microbes then eat those gases and will produce ethanol or other products that can be used as fuel. The biomass can be used as protein, and also then we can produce various chemicals and materials. But at the end of the life, we can really close that loop and enable a circular model. Now if we go to the next slide, just why biology. I think I've already mentioned that the ability to really kind of use different gas compositions. I think that's really important if you work with feedstocks that are very chaotic. On the right here, you can see a plot from a steel plant, and the left side from municipal solid waste. You can see it's very inconsistent, even for a steel plant. I think it changes quite a lot. If you think something like municipal solid waste, I think there you really have extreme changes, and that makes it really difficult for traditional technologies like Fischer-Tropsch. But the biology, as you can see, can still produce a very steady output, and it's very small. But if the right-hand graph here is really kind of from one of our commercial plants using steel production, and the graph goes from June 2020 to February 2021. So I think 8-9 months of really continuous operation. Click forward one more slide. I think one of the other aspects why biological systems are very robust in terms of these fluctuations is that they can regenerate. So obviously one thing that our catalyst cannot tolerate is oxygen. So I think it gets inhibited, but once you take that out, it can recover, which I think is not the case for traditional thermocatalysts. We go forward. I think we spent a lot of time then, I think, scaling this process. So LanzaTech's actually around 15 years, and we spent over 10 years, I think, scaling this process through multiple pilot demonstration units before in 2018 we reached full commercial scale. So on the next slide, you can see one of our first commercial units that we started in 2018. Meanwhile, we have multiple plants. If you go to the next slide, I think we have today, this is one actually of our most recent plants in Europe, in Ghent. So it's next to a steel plant of ArcelorMittal. Just to give you a sense of the scale of the process, so I think it's about 750,000 liter bioreactors that you can see here, where the process happens. And if you go to the next slide, I think we have now 6 of these commercial plants. I think between 33,000 and 64,000 tons of ethanol production capacity per year. After the first plant in China, we've got now 4 plants with the same group on both steel and ferroalloy gases. The one in Europe that I just showed you is also a steel plant. And in India, we just started last year also a plant that uses refinery off gases, which are very rich in hydrogen and CO2, sorry. And in addition to those feedstocks that's more using industrial sources, I think we also, on the road of commercialization of Solid waste, in Japan, we're working with Sekisui on municipal solid waste. That's certified. Right now, I think it's used for power production, but we can offer with our technology a path to more valuable products and something where we can use the carbon products displacing fossil carbon. We've operating on pilot scale there since 2013. We started in 2022 a 1/10 commercial unit, and we've just announced our first master license agreement now with Sekisui. If we move one step further, the other new feedstocks, I think we're looking at using just CO2 and green hydrogen, and we've just been awarded a contract also with Jackson Green and NTPC in India, where we use that 100% CO2 and green hydrogen as a feedstock for making ethanol. If we go forward, I think we have a strong pipeline of projects. In particular, we're excited. I think over the last quarter, I think we moved the NTPC into the post-FID and construction phase. So as mentioned, Sekisui, we moved that. We signed our first master license agreement and now looking to move that forward. And also, I think we just announced in Europe another project. This Aramet, where we're looking at a full CCU and S integrated project. If we go forward, I think the 6 commercial plants that we have today have the capacity of abating 500,000 tons of CO2. I think so. We're starting to really make an impact, and we're looking to numbering that up, of course. At the same time, we can also make 300,000 tons of product. And shifting gear now a little bit to that, I think the products are already used now in over 100 different commercially available products. And if you go to the next slide, so here you can see some of these products that are available to consumers today. Working with a variety of different global brands. In particular, I think apparel, I think cleaning products, detergents, and then also sustainable aviation fuels are products categories that we're working in. And the next slides have a few examples. So one of the first one was, I think, this beautiful cocktail dress here with Sarah. But if you think about it, Sarah probably would never thought about partnering with a steel plant or a steel plant being a feedstock provider for or working with a company like Sarah. So it's a really completely new value chains that's been enabled. We move forward, I think right now we have, I think you can buy various products. I think this is one example, REI. I think I'm wearing a shirt here from On, that's with recycled carbon, that's available today. If you actually go to the REI homepage, you can type in LanzaTech and you get those products, which is really cool. I think there's other examples also like Atleta that we just announced a collection. I think Adidas has a collection now and others brands as well. Craig Hoppers. Coty with Gucci has a perfume that's 100%, the alcohol is 100% the LanzaTech ethanol from recycled carbon. We have other, if we go forward, other kind of work with Unilever for various detergents and cleaning products, and also with Mibel and Migros. And actually in this case, also the packaging is made out of a PET derived from the recycled carbon ethanol. We move forward, I think through synthetic biology, then we can also enable to make other products in ethanol. Really, the key advantage there is I think we change the microbes, but then can use the same hardware, the same reactor. And we're working on a bunch of different platform chemicals. And if you go forward, I think one example is acetone and isopropanol, the C3 platform chemicals, which we've really optimized strains for high rates, high efficiency. I think some of that work is published in Nature Biotech, including, I think, some life cycle analysis that you can see here, where we traditionally, I think there's a 2.5 tons of CO2 produced per ton of acetone you manufacture. In our case, we can almost turn that around, and it can not just be carbon neutral, but carbon negatives. And of course, I think it depends what you do with it. If you use it as solvent, it goes back, but if you use it in kind of acrylic glass, for example, it can stay locked in there for quite some time. And in fact, I think we have now already kind of IKEA, for example, has those polypropylene containers now. If you go to the next slide, I think the other thing that we've been looking at and worked on is really kind of upgrading of the ethanol and feeding the ethanol into existing value chains. So I think obviously from ethanol to ethylene, once you're there, you have a whole range of applications like polyethylene, PET. But also, I think together with PNNL, we've developed a catalyst to turn our ethanol to a sustainable aviation fuel, which we spun meanwhile out into a separate business, LanzaTech, that was formed in 2020 with support from various airlines and other investments. Go to the next slide. I think before that, we've already had transatlantic, transpacific flights with Virgin Atlantic or ANA, and got through the whole ASTM certification. And yeah, we're really excited that I think LanzaTech now has opened up the world first alcohol to jet SAF facility down in Georgia, in the south of the US. And really, I think the combination of LanzaTech and LanzaTech really offers a lot of potential. I think one reason for spinning out LanzaTech was also, I think, opening up to the diverse range of ethanol sources. But if you look at the predicted growth of SAF, if we can go back one slide, HEFA is, I think, right now the dominant technology, but it's inherently feedstock limited. I think ATJ from traditional ethanol sources, I think we'll certainly see a lot of growth. But then beyond that, I think gasification and power to liquid and direct air capture, I think really kind of will be a lot of that growth, which can come through the combination of LanzaTech and LanzaJet, for example. Yeah, if we move on, I think it's obviously a lot about feedstocks, and I think the last point I wanted to touch on is really as a natural extension. We're also now looking at our food system. If you go on one slide, I think the biomass we can produce in the fermentation can be a sustainable source of protein. In our traditional process, I think the proteins already used as animal feed. But now we've developed a new microbe that just makes protein and from CO2. So I think we're looking at a process now making protein from CO2 and hydrogen, and as a primary product. And that protein is very comparable with P or Y protein. It has very rich in protein content. It has all the needed amino acids. And continue one slide. I think, yeah, we've already worked with partners like Medicine to develop really ingredient applications from protein shakes and snacks and bars to meat alternatives and bread. And we're right now in the process of getting GRAS certification. And again, I think to just some of the benefits here, I think one facility can produce 45,000 tons of this protein a year. Requires very little land and very little water, whereas kind of this can replace, I think, a protein from about 80,000 cows and 1.6 million acres of land and over 200,000 swimming pools of water. And then, of course, I think it's another key pillar to the market that we can access with our technology. If we continue one or two more slides, I think, yeah, we want to enable, and I hope I could show you that there is a path to a carbon economy that's circular. I think as a bioeconomy, I think getting to that first commercial and then to that diffusion, crossing that valley of death is obviously something that's really critical. So I think we're thinking also how we can help others crossing that valley of death, not needing to spend 15 years of scale up. So I think some of the capacity I think we're seeing there that we can help really is with our bioreactor technology. That's really kind of best in class gas mass transfer. And also, I think our ability to work with non-model microbes, for example, we developed this, if you go to the next slide, anaerobic biofoundry, where I think we can enable automated strain engineering and do that in context of anaerobic or contained condition and also different environments, including toxic flammable gases. So I think we do think this is a capability that could enable other technologies as well. So we spend a lot of time developing that. And finally, I think policies are obviously critical as well, and we need policies that are technology neutral and support all solutions. With that, I think it's probably time to wrap up. Obviously, we hope to make an impact on this important challenge along with other technologies. And yeah, happy to take any questions, and thanks for your attention.
Thank you, Michael. It's unbelievable what you guys are doing across so many different vertical markets. And, I know we have a bunch of questions here in the Q&A, but let me be the first to just say thank you again for joining us. You guys are doing really important work. And given all of our work in the SAF space, your name keeps coming up as the place to go. We've had some recent challenges, shall we say, with some competitors in the marketplace, which I'm sure makes it hard for you. Okay, so I'm going to go to the Q&A. We'll get as many of these in as we can, but keep your questions coming because we'll publish them. And Michael, with your permission, if we don't get to them, we'll send you an email with some questions and hopefully get some answers back for folks. Our first question comes from Lauren Steenhock, and he's asked me to read it because he's calling in remotely in some noisy areas. What applications has Lanza considered adjacent to traditional ethanol plants? For example, taking CO2 from traditional ethanol fermentation and adding H2 to create a separate green stream.
Yeah, no, I think excellent point. It's something that we certainly look at, and we've have some projects now where we're looking at exactly that. So obviously in the traditional ethanol plants, I think you have a third of the carbon, I think, going out as a CO2. It's a very clean stream. So I think that's great. I think and then if you can generate green hydrogen, that's something that we can use as feedstock. I think it's particularly interesting where you have where you're not, for example, able to feed that CO2 into a pipeline. And I think if we can just co-locate our plants, and I think we can either increase the amount of ethanol or obviously I think also add other products. So I think that's certainly an exciting area as we see, especially I think here in the US. Yeah.
Excellent.
And yeah,
Thank
would love
you.
to discuss more project in that regard. Yeah.
Okay. And we have a question from Chuck Sorensen. Chuck, can you unmute yourself and you can ask Dr. Köpke his question? Chuck, are you there? All right. Well, I'll read Chuck's question. Again, for those who have put questions in the Q&A, when your name is called, please just click the unmute on your microphone button up top and you can ask. Chuck asks, what are your biggest scale? Oh, okay. There you are, sir. That's
I
okay.
had a lot of trouble finding the silly icon. I was looking for something that said unmute, not mic. My apologies. Michael, my question is, what are the biggest scale-up challenges still ahead for LanzaTech? Because like the European steel plant is what, 64,000 tons per year of product capacity, that from a fuels perspective, it's really quite small. And so I was wondering, what would it take to make mega plants out of LanzaTech technology?
What would it take? So certainly, I think you need to have the supply of gas in one source. I think we certainly think about both. I think can we go bigger? Which I think from a technology perspective, we don't see why we couldn't and take advantage of the economy of scale. I think right now, I think the first plant started really kind of being in that kind of traditional corn ethanol size. I think that was a kind of a size where I think the investment was there. I think the technology scale up makes sense, but I think we certainly don't see any kind of hurdles going bigger, and I think taking advantage of that economy of scale. So I think certainly you need to have the obviously gas supply for it. But then I think likewise, I think we also see an opportunity where we can be distributed, especially around waste solid feedstocks, where I think you don't want to make sure you have local radius and don't invest too much energy in the transportation. But where we have point sources, I think certainly, looking at going larger, making use of the economy of scale, and then also I think where we can integrate with downstream processes. So,
just as a follow-up, the lift fermenters, can they be made any larger than they already are?
Yeah, we can certainly, I think, still go larger with our reactors, and then obviously you have the opportunity to be modular as well. I think in particular, I think we've now, I think, launched our second generation bioreactor, which is more intensified. So yeah, it's in addition to going larger, I think obviously process intensification is the other area that we're working hard to make the process more efficient. Yeah, was the same size of land. Yeah.
Thanks, Chuck.
Appreciate it.
Michael, one of our esteemed leaders, Admiral McGinn, has a question. I don't know what it is, but he's raised his hand, so we're going to ask Admiral McGinn to unmute, and he can ask you directly.
Hey, thank you, JD. Michael, terrific presentation. Question, anytime a company like Lanza wants to really expand and grow and increase impact, it's usually based on what I would call the three-legged stool of finance, technology, and policy. So with the change in government, if you will, in the United States that's pending, do you see any speed bumps or roadblocks by having an administration that ostensibly doesn't see the value in carbon recycling? Perhaps the argument has to be this is great for economic development and job creation, but if we say, gee, we don't really care about climate change, it's a hoax. So things like carbon recycling really aren't that important. My key question is, do you see any roadblocks, or probably not roadblocks as much as speed bumps ahead to your continued growth and the growth of similar industries looking forward to the next 4 years?
Yeah, no, I think really good questions. I'm not a politician, of course, but I can speak a little bit to what we think as a company or as an individual. So I mean, for one, I think I do hope that I think some of the climate things stay on the agenda. But certainly, I think it's also those other arguments. I think the IRA is obviously something that's been very beneficial for the whole field, and I think at the same time, I think generated a lot of jobs, also a lot of projects. I think in kind of more Republican states. I think, and that was actually one thing that I think was started earlier. So I think that I hope that will certainly stay on the agenda. So I think that's been a very good program. But I think what certainly I think important to me is that I think it gives clarity now. I think there was a lot of kind of maybe inaction because it wasn't clear what direction it will go. So I think that's falling off. And then for us, we certainly, I think, yes, it's certainly a big focus for us, but we're a global company as well. I think we're developing projects globally. So I hope that the US will maintain a leadership, and certainly aspects like the economics, like domestic supply, that I think will also be continuing to be important, I think. Yeah. I'm interested also to hear your opinion or others' opinions. Yeah.
Given the broad spectrum of valuable products and feedstocks that you produce, the brand name companies, international as well as in the United States, I would think that network would be a powerful driver to continued economic growth and the benefits that carbon recycling can bring. But once again, great presentation, very impressive technology and processes.
Thank you.
Thank you, Admiral, again. Juan Diego Carvaja, could you unmute and ask your question?
Yes, thank you, Dr. Köpke. My question is more related to the differences between producing larger molecules, like molecules larger than ethanol from synthetic biology versus producing ethanol in the bioreactor and then doing chemical synthesis. So maybe you have in mind what differences does this integration bring, like let's say advantages or disadvantages, and maybe I don't know if when you are doing this integration, do you need to dissolve more reducing equivalents to like the proportion of reducing equivalents to carbon needs to be increased even more than the waste gas already has, or?
Yeah, I think obviously it's always important to look at the energy conversion rates. I think where I think biology is really powerful is, I think, accessing this diverse chaotic feedstocks and turning that into a specific selective product. And then I think there's certainly a lot of good existing chemistry that's there to diversify. So I think at LanzaTech, we certainly try to look at combining the best of both worlds. Certainly, I think for getting to molecules like SAF, we saw the fastest path being through that using biology to produce ethanol, but an ethanol to longer chain SAF-like molecules through kind of existing thermocatalytic processes. I think there's certainly opportunities for synthetic biology also to develop longer chain molecules. I think right now we're mostly focused on those kind of C3, C4, C5 building blocks for the chemical industry, and then trying to make use of existing technologies, and also look at where biology can make specific molecules like the proteins, for example, that's more difficult to make otherwise not using biology. Yeah.
Okay, thank you.
Excellent question. Thank you. Next up is David Peterson. Are you able to unmute, David? Michael, you've generated more questions than any guest we've had, and I don't know how long, so we're never going to get to all of them. I'll go to the next one. Mike Sticklin had two. Michael, choose your favorite, and we'll go from there.
Okay. Yeah, thanks, JD. Great presentation, Michael, and fantastic job of branding through the vertical supply chain. That's really impressive. The question I've got, I'm in the ethanol business a lot here in Iowa. You mentioned bolting onto the end of a pipeline that they're trying to build here. They've been trying to build it for a while. But my question really is, taking that biogenic CO2 from an ethanol plant and using your technology to convert it to a higher value product, does that also qualify for the 45Q tax credits?
I think that would qualify for that.
Okay, so that's another benefit in addition to producing a value-adding product. Yeah, okay. Thank you.
Next question comes from Benedict Yeager. Would you like to unmute?
Hey,
there
yes,
you go.
Thank you for the great talk. I just had a question regarding to the synthetic biology that was now hinted at. How do you plan to tackle like evolutionary escape from your biological catalyst when you're running a continuous process as you do away from the production of those heterologous products as isobutanol or acetone?
No, excellent question. I think obviously running a continuous process, I think you need to monitor that. And I think especially as you start making different products, I think that's maybe different growth rates. I think there's considerations to that. I think we have a couple of different aspects we're looking at. So first of all, I think we always try looking at can we combine the metabolic engineering with coupling that to energy generation or to growth. I think if you can enable growth coupling, that obviously gives you a big advantage in a continuous process. And then you also have both on the strain, but also on the engineering side, I think opportunities, I think for selective conditions or pressures or kind of markers that you can employ as well. But it's something that for a continuous process is important to consider.
Okay, yeah, thank you, great.
And certainly, I think would hope that there's more work towards continuous processing and fermentation in biology. I think that's still an untapped area, mostly untapped area. Where still a lot of potential to improve bioprocesses in general.
Certainly.
Okay. Stephanie Eot. I'm going to butcher that name. If you're able to, Stephane, able to unmute. I'll ask the question, and I apologize if I'm misdoing gender here, but acetogens are generally good CO transformers, but poor CO2 ones. How do you make them able to transform efficiently CO2?
Yeah, I think there's both some acetogens that grow well on CO, some that doesn't grow well on CO, but on CO2 hydrogen. The strain that we're using, Clostridium alternate genome, is able to use both. So I think we've certainly, I think, looked at then also optimizing strains more for certain types of gases. So, for example, adaptive laboratory evolution or also synthetic biology, we can have strains that are maybe more efficient on carbon monoxide, more efficient on carbon dioxide, hydrogen, but still, I think, maintain that flexibility.
Okay, awesome. We have literally like 2 minutes left. We're already 15 minutes past, so thank you for being here. Next question, maybe let's make this the last question. Richard Harrison had a question.
I think I got it. Okay. Michael, great presentation. I was just curious. I saw when you were closing out your slide deck here, there was a brief reference to cell-free, and which is an area of interest to my company. We're working on cofactor regeneration. And so I was curious if there were any particular areas that you saw promising for industrial scale cell-free biosynthesis.
Yeah, no, it's certainly a field I'm very excited about. So I think we do have a cell-free conference. I think it's called Cell-Free Systems, I think, coming up next summer in the Chicago area. So hopefully some of you will be able to maybe join that one. At LanzaTech, I think we mostly use cell-free as a prototyping tool, especially if you work with non-model organisms. I think if it can prototype pathways or aspects of pathways in vitro, that's a much faster way. But I still see a lot of potential in cell-free as use as biomanufacturing. I think there's obviously some hurdles. I think you still need to make the cells, and I think that's part of the cost. And then I think the cofactor recycling, as you mentioned, I think is probably a really important aspect of the puzzle. And then I think, but I think so it offers a lot of exciting opportunities. And I do see some progress in that field, also using cell-free now towards more commodities, or maybe at least specialty chemicals. So yeah, I'm hoping that there's going to be continued growth, and that certainly I think how you make the cells with the feedstock, and I think cofactor recycling will be, I think, keys to unlock. But cell-free can certainly, I think, add some take away some constraints that cellular systems have.
Michael, thank you for everything, for going over, for soliciting so many questions from the audience. We're going to have to put them into a large book, which we will FedEx to you. But we'll get you an email with all questions that weren't able to be asked or answered here, and we will just say thank you so much. Really, just an incredible depth across so many vertical markets. Not one stumped question, which is a terrific testament to you. We're going to move into more internal conversations about some new experts and other things. You are welcome to stay, but we really wanted to just say thank you, and we look forward to working together with LanzaJet and LanzaTech in a variety of different fields. We keep intersecting with you, with our clients who are looking for solutions. So we will look forward to continuing the relationship. So thank you again for
Great.
everything.
It's always a pleasure to talk to the group. Yeah.
All right.
And looking forward to any follow-up or any further questions. Yeah.
Terrific. Thank you so much.
You.
One of us will be getting you a quick synopsis of all unanswered questions, and anything you can do to answer them, we will distribute them out to the folks who asked them. So thank you. All right. That was amazing. So we're going to run a few minutes over. I'm just warning people ahead of time. But we are not going to skip on our new experts. First is Dr. Benjamin Reed from the great state of Colorado, with a variety of expertise across biotech, pharma, renewable energy. Seems to have done it all. And if you would be so kind, Dr. Reed, if you could give us a couple-minute introduction to the team, we'd be grateful. You can use camera too, if you'd like. Dr. Reed.
JD, he shows is on the call and maybe having some trouble locating his mic.
Okay.
We move to the next, and we can go back and try it when.
Okay. Terrific. Yeah, message Ryan, Dr. Reed, if you get a chance. And Jim Blair, I've had the pleasure to have met and spoken with. So, Jim, welcome aboard. If you would be so kind as to take a couple of minutes and introduce yourself to the team and tell them where you've been.
Sure. I'm James Blair. I'm in Dallas, Texas. And I joined the team here very recently, working a little bit with Pete Roca on a project that we're still hoping that will occur maybe in the new year. I'm involved. My history has been in the oil and gas business and the exploration and production end of it. But in the period during COVID, I got involved with a blue hydrogen development project, which is still under development in Louisiana, a very large project. And began to understand a little bit more about the production of hydrogen and ammonia and its offtake and the markets that they will try to serve from that facility. From there, I moved over into the green hydrogen business, working with an Australian company to develop a plant that was or that is being built now. We reached FID in 2023. This was a 80 megawatt facility that will produce about 30 tons a day of green hydrogen for the mobility market, mainly for the Class 8 trucking market in Southern California. And then taking those blue and green experiences and have continued to work with off-takers in the blue sector of the business. And then more recently, and this is kind of getting to the project that Pete and I worked on, and that is I've developed a startup company, or have started a little startup company that is exploring for geologic hydrogen in the mid-continent, specifically in Kansas, but other places as well. But we're developing our target models and our target exploration theories behind why we want to drill in specific spots for geologic hydrogen and what makes it attractive in those areas, and what are the challenges for not only identification but commercialization for that for the hydrogen that we may find in those areas. So together with those three experiences, blue, green, and now geologic hydrogen, I feel like I've got a little bit of commercial capability that I can bring to LEC. We've already had discussions with a couple of groups that wanted to do some things in the geological hydrogen business.
Right.
And we hope to do that here again in the new year. So very much
welcome aboard.
Pleased to be in the group.
Dr. Reed, any chance you have found your buttons? Maybe he's in the car. Well, we're excited to have you. And now, without last but not least, a guy that I think everyone who has worked with him has nothing but incredibly effusive things to say. I've had the pleasure of working with him. He knows more about LCAs and other things than most folks will forget in a lifetime. But Stefan, you came as such a highly recommended all-star. You can see the quotes from Glenn, Terry, David, Michael. Everyone says the same thing, and I've had the personal experience. Your depth of knowledge, your ability to help our clients is incredible. And so we would like to present you with an all-star award. And I think that means we'll send you a little something, but just to say thank you for all the work you do for us, with us. I know you do a ton on your own as well, and we look forward to doing more and more together. So Stefan, if you're there, pop on video and audio and say hello.
Fantastic. I am. Thank you very much. And I enjoy working with all of you and bringing 4 decades of memories to insights that are part of our universal consciousness.
We are thrilled that you are a part of our team. You bring incredible gravitas to the areas you focus on. And again, I know you've had a hand in crafting legislation. Like the credibility is unmatched. So we are thrilled that you're a part of our team. We'd love to figure out ways to do more with you. And thank you again for everything you do.
Thank you very much.
We will get you something. I don't know how we do it, but anyway, look in the post. So sign up for your monthly our monthly newsletter. We're now publishing on LinkedIn. We also have an email version. If you are not currently receiving this information, you should be. So please sign up. And what's next? Ryan, is that a see you later? It's literally 12 on the nose. For my first webinar, I would like to say thank you to Ryan for queuing me in the back and making sure everything goes well. And to everyone who has joined, it really is a pleasure. What a treat to hear Dr. Köpke talk about LanzaTech and LanzaJet and all the things they're doing. And I appreciate your patience and thank you very much. We will collate those questions that weren't answered. We will get them to Michael, and I don't know how we'll distribute them. Ryan will send them back out, I guess. What's the best way to handle
Yeah,
that?
JD, we'll get that list and probably post Michael's responses with the recording video that we have. It may take a little bit, right? Because there were several questions, but we'll make sure we get those published out.
Terrific. Okay. And for all those who work at LEC, thank you for joining. For all of those considering working with LEC, thank you for joining. We hope you found it to be educational and useful, and we'd love to have a chat with you if you are inclined or if you have a problem that we can help with. And that's it. I hope everyone has a good rest of day. Thank you.